Hello, welcome to Andrew's Learning Center. Today we're going to be making a DNA translation app. So before we begin making the app, we must fully understand what DNA translation is. So I will start with a brief introduction on DNA translation for those of us that aren't familiar with biology. To understand what DNA translation is, one must fully understand the central dogma of biology. The central dogma essentially describes how genetic information is encoded and how it is eventually used. So in the central dogma, there is essentially a macromolecule that stores genetic information called DNA, and that is eventually transcribed into RNA, which is eventually translated into resulting amino acids or proteins. In all of these macromolecules that I just described, they are all long chains built up of singular units called monomers. So the monomers for DNA and RNA are called nucleotides. The monomers for proteins are called amino acids. All of these monomers that I just described are symbolized in biology with letters. So essentially our app is going to take a long string of letters of genetic information and then translate it into its resulting amino acid chain or peptide chain. So that's pretty much all the information you need before we begin building the app. So why don't we go ahead and get started? Alright, so let's start coding, guys. To start us off, I opened up the Integrated Development Environment, or IDE. This is VS Code. An integrated development environment is just an application that allows coding to be a lot easier, and VS Code is the way to go if you ask me. So to start us off, I made a Python dictionary of codons. So essentially referencing what I spoke about genetic information being symbolized by letters and the resulting amino acids being symbolized by letters. So a codon is essentially 3 nucleotides that will actually produce one amino acid. So this is adenine, thymine, and adenine again, ATA, and that will produce isoleucine, the amino acid. A Python dictionary has key value pairs. It's essentially a data structure that allows us to store information, and you can, like I said, you can define a key, and if you call this key, it will return this value. So let me show you what I mean by that. So if I call in this dictionary AAC, if I'm like, what does this key symbolize? So I defined AAC as N. So that's how that works. To begin, I'm going to make a function called translation that takes in a DNA sequence. Next, I'm going to make an empty string called protein, and this empty string, a string is anything in quotations, is where we will add the amino acids as we decode our DNA. Oops. Next, I will make a for loop. So before we continue, let me explain some of the code that I just wrote. So a for loop is essentially something that'll take a list or something, anything in sequence, and it'll iterate through each item in that list and do something. So let me show you what I mean. So in this for loop I said for each number in the list X, print the number. And it returns all the numbers printed one by one. So that's kind of how a for loop works. This for loop also uses the range function. So the range function is a function that uses different arguments. So it has one argument start, one argument stop, and one argument step. So start says where we're going to begin. stop says where we're going to end, and step says how are we going to increment through beginning from start to stop. So how are we going to increment through? So essentially I said we're going to start at the first DNA nucleotide, then we're going to go towards the end of the DNA sequence, and we're going to go by threes. Next, let's define our codons. So what I just did was I sliced the DNA that the function took in. So what is slicing? Slicing is essentially, it uses the same notation, start, stop, and step. So in this case, I just had start and stop. So let me show you how slicing works a little bit. So if we count from 0 to 5, 0, 1, 2, 3, 4, 5, that's actually 6 numbers. But because we end at 5, the sixth number is actually not included. So in reality, it's 0 to 4. But the fifth number, like I said, is not included. So it just counted these 1, 2, 3, 4, 5 numbers instead of 6 numbers like you would actually think. So in the case of our DNA, we actually, instead of adding 2, so beginning at the first number and then adding 2 more, we actually add 3 so that we can actually get 3 nucleotides. Next, let's add a little bit of logic. Okay, so what I did here is I said if the codon is in this table, I actually want you to find the value of that codon, like see what amino acid it's defined as, and set it equal to the variable amino acid. And if it's not there, just set it equal to the variable X, as in there's no amino acids there. Next, let's wrap things up. Okay, so let me just explain what I did. So in data types, in many programming languages, you can actually add similar data types. So let me show you what I mean by this. So I have two strings, HE and LLO. So I'm going to add these together and get hello. So essentially what I'm going to do is I'm taking this empty string and I'm adding each amino acid to it so that, at the end I can print the protein chain. So let's see if this works. Okay, so I took ATA and I got isoleucine, and then I took GTA and I got valine, and I took GCA and I got alanine. So it looks like our program works. Let's make it a little more user friendly. Okay, so essentially I decided to use the input function. So let's see how this actually works in practice. So how the input function works is it is a function that takes in a string, and it uses that string to prompt the user to then get their input, and whatever their input is stored. So essentially I'll store the input in this variable, and then I will actually print this variable. So if I see how this works, it's going to say, how are you? And I'm going to say, I am good, love learning at Andrews Learning Center. Because we all do. Okay, cool. So it printed what I input. So I am good, love learning at Andrews Learning Center. So in this case, the function will actually prompt the user to give a DNA sequence in which they can give. So let's look for a common DNA sequence online. Okay, so we are at the National Center for Biotechnology and Information database, and we're looking at the protein insulin. So if we look at insulin's DNA, copy this. So now if we have that copied, we can run our app. It prompts us to give the DNA sequence. We can paste it in, and voila, we have a long protein sequence. So that's pretty much it for the app. Thanks for watching. So that's the end of the video. Thanks for watching. Don't forget to like and subscribe. Really helps the channel. If you're not familiar with our Instagram, make sure to check it out. Instagram.com/AndrewsLearning. Got a lot of cool stuff up there. You know, building things, synthesizing things. I'll add the link in the description. So yeah, y'all take care and tell a friend to tell a friend.